Hi all, Sean here, and this is part one of a multi-part series that's going to explain how to update results using the automated DRE version 2.0 software. Uh, part one will explain where the files are stored that the DRE program produces and how to interpret the contents of these files. So I want to start off in Windows File Explorer here. You can see I'm in the root program data automated DRE. This directory is made automatically when you install the program. And you'll see here we have this folder called LAN data. If we walk in here, we'll have our list of folders for everything that we've collected organized by fab ID. If we click into a fab ID, we have all of our POUs that we've collected data for under that fab ID. And inside here, we have a collection of folders and a file called processdata.json. This is a new file that will allow you in version 2.27 and forward will allow you to store like different process related information. It's an optional in the DRE program, but we're not going to focus on that. We're going to focus on the actual data that is collected. So we see we have these three folders here. Flows, if we walk inside, it's a JSON formatted file. This contains the contents of this is the like summary results of the flow test performed. It'll contain information like the total flow calculation, the errors associated with that flow for all of your inlet and outlet sources. Let's back up a folder. So flow data is sorted into inlet and outlet, but they're the same just depending upon inlet and outlet. And these are the concentration results that were collected during the flow test. So these would be, if you're using SF6 as your tracer gas, it would be SF6, a timestamp, and the actual concentrations, and then a marker that distinguishes whether it was that point was used in run 1, run 2, run 3, or not used at all. And after I explain this file location, I will go back through and show you what all of these files look like. But for flow data, which is the concentration results of your flow test, we have, for inlet and outlet measurements. And then this is our DRE folder. Again, we have inlet and outlet. And if we walk inside, we'll see that there's a folder titled, with the .DRE extension. This is also a human readable format. It's can load into Excel if that's how you'd like to look at it. That's how we're going to look at it. And it actually contains the results of the actual DRE test. So give me a second and we will come back right back and show you what each of these files look like. Okay, we're back. I have pulled up a Microsoft Excel file and I've loaded in an example of each of these file formats into Microsoft Excel. You don't need to use Microsoft Excel if that's not what you prefer to use. All of these files are human readable. They can get loaded into any document parsing program. But for our cases, because we're dealing with a lot of tabular data outside of this particular example, I chose to load it into Excel for simplicity. But here we can see I have an example of what the flows file is. That's that JSON file, and it's basically a summary of the flow results. So we have, for example, we have for inlet number one, we have the number of points that were measured. We have what the average concentration was for run one, run two, and run three, what our measured flow rate would be, the number of points for that particular run, the standard deviation, and then what the tracer flow rate actually was being released. And we can see, we scroll down, we have some total numbers here, total flow rate, total error, the name that was given to that particular inlet source. And you can see we just kind of repeat this over and over again. Inlet 2, inlet 3, inlet 4. If you didn't, inlet 5 doesn't seem to have collected anything. It'll just have zeros in it. Inlet 6, an inlet total. So this will be the total results of all the inlet runs that actually occurred. And then we repeat for our outlet. So simple format. Again, JSON, Excel and JSON, not the best way to maybe visualize this particular data set, but you can hopefully see what's going on in this file. So now we'll go over to the flow data. Again, this is the concentration results of the flow test measurement. The way these files are all structured is that at the top we have some metadata that is prefixed with this the pound symbol here. And so we just some identifying pieces of information. But the meat of what we care about is it starts here. So we have this timestamp, like a Unix timestamp. The actual concentration you can see for this particular run, we used SF6 as our tracer gas. This would be something different if you used a different gas, for example. And then this run number flag column. And so if we kind of scroll down here, we'll see these are all concentration units. And we have in this run number column, we kind of have a bunch of zeros, then we hit a 1. So this would indicate that this was the beginning of flow test number 1 for this flow source. And as we scroll down, we'll see that eventually these ones end. So this contiguous block would be all of run 1. And if we continue down, there's run 2, the end of run 2, and run 3, and the end of run 3 ran all the way to the end of the data that was collected. And what I've done here, just on the side, this is not actually in the file, of course, but I just plotted it, this data, so you can kind of see, and I change the color over the regions in which the marker was 1. This would be run 2, and this would be run 3, just to highlight how you can interpret the contents of this file in terms of what actually occurred. And last but not least, we have the actual DRE file. This is the actual results that are stored from the DRE test itself. Yeah, um, it's a large file, but what I've done here, just for simplicity, is I've chopped it down to just 3 compounds. Normally you would have many more compounds. Everything that was in the UI when you collected it would be in this file, but it all follows the same format that I'm going to walk you through. Again, we have some metadata up at the top, prefixed with the pound symbol that you're welcome to look through. Maybe the most important one, is it does have a record here of what the total flow was for this particular one. You're going to have one of these for the inlet and the outlet. Remember, they'll be in different folders, as I showed in the beginning. And then we can kind of see that we used a manual region where we moved in the UI, we moved and selected 3 regions, manual regions 3. And so the way this file is formatted, again, we have our timestamp in human readable and a Unix timestamp. But then after that, every 5 columns is going to be a piece of data related to a particular compound. So you can see here, I've got this region here in yellow is not actually in the file that you'll see. I added this as a teaching tool. So we have 1, 2, 3, 4, 5 columns. They correspond to the concentration result for that point, the concentration detection limit that was recorded for that point, the volume integrated across that point, so that would be in liters, the associated DL and volume units, and again, we have this flag, this is what I call the include flag. And so each compound will have these 5 columns, and they'll always be in the same order in this file. But you'll have, so for example, here we have CF4, and we have CH2F2, and we have SF6. And so the way it works is basically this first column is all of the concentration units for CF4. This first column would be all of the detection limit results for CF4. This first column would be all the total volume in liters for that particular interval of time for CF4, the associated DL in liters for CF4, and this include flag, which is similar to what we did in the flow data file. So if I scroll down here, eventually we'll hit a 1. Eventually, there it is. So this would say that here's this region was determined to be the start of this particular point time in which we wanted to accumulate towards our actual sum for our total volume. And you can tell from this file here that with these pp, this concentration being 0, that this is the inlet, an inlet DRE file, because you supplant below detection limit with 0 for the inlet. And actually, if we go up to the top here, yeah, we can see it was indeed inlet. So that's how this file works. The only outlier to this structure that I defined is the very last column that contains data will always be this time in minutes field. So this would be the total time elapsed between points that was used to produce the total volume. And so you can more easily back that out rather than having to perform, differential logic on maybe these timestamps, for example. And so that's the structure of the files and where they're located. In the upcoming series, we're going to show how to view this data that has been previously collected in the DRE2 program, and then we're going to show how to reprocess for concentration results and install that into the DRE2 program to update our DRE results.